Okay, thank you very much. A short introduction from my side as the chair of the product program of buildingSMART International. So very happy to have you here, especially people in the room. So the room is feeling a little bit more than it was at the beginning. Thanks to be here.
Fresh air.
But fresh air, I don't believe you. He's a smoker.
Let's define fresh.
Anyway, so thank you for being here in Montreal and on site here in the room. Thank you to the participants outside that are here online. We will have two activities that we raised within the product room that we'll present today. So the first one that is presented by Robert Heinze about IFC for products. So an activity how to provide product data via the data exchange for IFC. That is something that is right on the border to start a project within the product room to develop this further on. And he will give us an update. And the second part will be by Morten, Loes, and by Hansueli, Schmid. That's about concrete implementation. Also on IFC, but especially with the data dictionary, how to bring in LCA environmental indicators into the data dictionary, publishing for manufacturers, wholesalers to publish then at the end of the day environmental properties and content for the community. So I will hand over to Robert for the first presentation.
Yes, hello. Can you hear me?
Yes.
Perfect. Okay, let's start with the presentation. Yes, as Michel mentioned, it's about IFC for products. This is something which is for interest for me for a longer term. So I guess since 10 years, I'm trying to have something like IFC for simple products. And this is about this presentation for now. First of all, let's have a short, slightly look into IFC. Not too deep, promised. IFC is something which is standardized, which is open, which is great for a lot of use cases, especially for transport digital buildings. So you know IFC, as I said, I will not go too deep down into the techniques. But IFC has one major lack in my eyes. This is that you can just handle projects, just handle buildings, complete buildings with the IFC structure we're using today. And this means we can transport quite easily complete buildings with an IFC site, with an IFC floor, and with IFC spaces for the rooms, and with products also. For example, luminaires, this is my industry, coming from the luminaire industry. You can handle luminaires with 48 properties in IFC natively, great stuff, including light distribution. But it's just always in building. You need to transport in building in order to transport IFC products. And this is about this proposal that we want to have a way to transport in IFC and product, but without to have the complete building structure around this product. And that's why we have a slightly name difference. So this is we call it construction object data. This is an acronym COD from the standardization we had on the SEN level and standard to do exactly this. But this will I show in one of the next slides. Yeah. First of all, this is the COD. COD means not other than IFC for products, just in another term. Why we should need this? Just one slide to have a thought about the scope. Because the industry, and I'm in a way a representative of the industry. I'm a representative of the lighting industry, and the luminaire manufacturers want to provide their data as the same way in window or in door or in whatever building construction object / product manufacturer wants to provide their product data in an open BIM way. You want not to produce an Revit file, an ArchiCAD file, and Nemetschek, whatever file you want to have an open BIM file or an entity, could be also something on a server where you link to. You want to provide your product data, and you have a lot of product data today as a manufacturer in all disciplines, in all scenarios, in all industries. And you want to provide this product data to your clients, to your users, to your designers, to the architects, to everybody who's working with your products. And this could be a lot in different ways. And you want to provide this data digitally in an open way like IFC. IFC is really great, but as a manufacturer, you have no access to IFC. Except you have a building which you can populate, or if you have an empty building and to transport your products in this way. So this is the motivation and also the scope for this, and really important foundation to do this. Also in IFC itself is to have a standard about properties. This is something which happens also more as a decade in the past. It is now working practice. This ISO 23386. This is a standard for properties. So a standard to having the properties of the properties organized in a way in order to create something of like a mapping core. This is needed as a foundation to create further on product data templates and further on an IFC for products in the stages, but also in the same way for the normal project-based IFC. This is also the same story. As I said, in IFC, you have for luminaires 48 properties, but the industry itself, the luminaire industry has about 500 something properties identified and also standardized on the ISO side to describe their products. And this is also across all the industries. Everybody has more properties of this product as you find natively in IFC, which is okay. This is normal because you cannot put anything in an IFC. This is close to impossible. Then it will be explode. So many properties and so many objects you can transport. This is something which is originally in the product room always discussed. How many properties you have natively in IFC and how many properties you have in, for example, in a property server like BSDD, which is external. And the concept here, the construct object data / IFC for product goes in the direction that we want to have a lot of more options which are existing in IFC used to use external properties, proxy properties, whatever, but with a link to a property server like BSDD to the system. Okay. Building on this, we can organize the properties in a way to building up objects, building up construction objects. And also, it's also a method to have this product data template to have some kind of request of a specific product. So this is something also more deep, and product data template is also something not just used for IFC product, it's also used for IFC itself and also for product communication. This is also something with a higher hierarchy and also standardized. Okay, next slide. Yeah, as I said, we need a lot of properties and structures, and for this is always a bit of more as we can have natively in IFC, and that's why buildingSMART did a dictionary, but also all other property servers with a certain structure, according also in standard 12006-3, is needed in order to have the completeness of the product description, the product IFC working in a way. So products have, of course, also geometry. It's not just about the properties and the template and the relation of properties. It's also about the geometry. This is also important for a lot of disciplines, a lot of manufacturers. And the geometry we found in IFC is great. This is based on STEP from the past. We have more options to create geometry, and this is also it's completely useful for products because products also have some kind of construction of them, and this construction of products is in a lot of, I will not say the most, but in a lot of industries for building products, you have also in similar way to creating step files in Express and to have a construction of your products, and this is really close to the IFC core. So this is and to create this stuff. Next slide is Yeah, and this is the first theme for the standard. The COD standard is existing as an draft. It's called EN 17549-1. There's also an -2. I have a slide later for this. And in a simple way, you can imagine IFC for products or COD, construction objects data, as the same structure as we have in IFC. It's also completely validated to IFC, just with another header. So we put out the header of the project IFC, put in a new header where it says, okay, this is now a product, not a project. And then we have an IFC project library. This is the layer for the project data template. Here we allocate all the properties needed to describe the product. And then we have IFC project with also the product data like in normal IFC from the structure. This is something where you can start to go into the structure. Of course, you need also to create this. The creation is something where you need to have some effort as a manufacturer, as this is not depending on the software and on the tools which are developed. At the moment, you have to handcraft these IFCs. You can, of course, use some modelers and to extend this, but this is something where we need some more best practice, some more examples, and would also be great to have some more tools in order, or some converters from some other project data. But it's also not so easy. There's not an universal project data format existing on the market, especially not in geometry and properties and so on, except of this closed BIM ones. So this is also a challenge for the industry to create this, but with the right tooling, with the right PIM systems, and good 3D models as an basement, like STEP, for example, this is quite easy to do, but this is in rate we have to go. Here we have an example. This is, for example, an example of in COD with an Lumina, of course, in my case. And here we have a Lumina. This is the geometry representation of this. And here we have special for luminas. Here we have a lighting distribution. So and how the light comes out of the lumina, also described here in the Express format. Works quite well. And this is an example on the XML serialization. So IFC for products can also be serialized in XML, but also in Express or in OL or whatever you have in serialization for IFC. This works in all cases. And here we have an example for an IFC XML based COD header, where we have the header structure. It's a simple header with name, origin, and a person, and so really the basics. It's not quite much in the header. It's a quite simple header. And here we have the product data template in a IFC XML form, so you can understand it as a human, better as an Express, I have to say. That's why we have here an example of XML. And here we have, for example, one property called Sen Flux Code. This is a Lumina property. Here we have an GUID, but here from an external source called somewhere. Yeah, it's an external source of this property because this is not native in IFC, for example. And what you have natively in IFC, you should also use natively in order to be understood with this property. If you're going to have a property from another property source, then it's depending on the application to interpret this. And this could be in some parts problematic. And here we have a product in this product data section of this file. And here I have a real product in Lumina with an filling of a value for this Sen Flux code, just as an example. And here we have also documents. It's also possible in IFC natively to have reference to documents, to assets, to files. So for example, here we have put in the IFC structure a light distribution file in addition, and also in PDF file for this is, I guess, a mounting instruction or a data sheet or something. This is also possible to use IFC and we do this also here in IFC for product to extend this with assets and files. Yeah. Part 2 of this COD standard standardization is something where we have more in communication about products. This is something where you can have some templates to query, to ask, and product database and catalog and dictionary for specific products. You can have your requirements on a product described in a PDT in this IFC for product, and then you communicate with manufacturers about your requirements. This is especially for Windows doors, etc., where we have a lot of customizations, where you have not in box good, where you have more complex products, and you can use this requirements and also this configuration part is also possible to communicate in configurable parts and in variants with this second part of the standard. So a bit more the complex roads ahead. Yeah, and if you are interested to have a look by yourself in this definition in the COD or IFC for products, here is the link on the GitHub site where you can have a look in the definition. This is similar to the IFC documentation. It's also created with IFC doc. This is a nice tool to have your own IFC MVD, and this is here described which parts are possible to use of an IFC. It's quite similar to the normal IFC. What I've said, just with some extended or some exchange parts in it. And this should be the last slide. I have to thank you for having me in Montreal. Greetings from Germany, where I'm at the moment. And now I'm open for questions and, of course, for a discussion, if possible. Thank you.
Well, thank you, Robert. Can you hear me?
I can hear you. Yeah.
I always have to check. Great. So, are there any questions here in the room for Robert? Yes. Yes.
I have one. I'm not familiar with the product structure standard that you displayed, but I am familiar with ISO 16757, which is about building services catalogs. And they did a lot of the very similar work to what you just described for mechanical equipment. Did you know of that standard and look to see how parallel it is to the approach that you took?
I have not heard about this, but sounds quite interesting. I would like to have this standard number again.
16757.
16757?
Yes.
This I know. Yeah. Sorry. Yeah. This I know. This is something also from Germany, which is also based, not really based on IFC, but we have now an standard, I guess it's .-4 or .5 of the 16757, which makes also in relation to IFC. So in the end, also this, I always call it the volume flow products description. So it's more for heating, ventilating, pipes and pumps and so on. And the standard is also going to IFC, and this is the meeting point of these two worlds. But the 16757 is quite specific for a couple of products. It's not the universal structure for all the products. You need to express your objects, your products in this way in order to be present there. So, for example, luminaires are not existing in 16757. It's possible, but then I have, or another colleague of the lighting industry has to create an object in this for luminaires. This is not happened to now. Maybe in future, it's possible, but this is the universal. It's a bit of more specific, but quite capital and open and useful. And I'm also a fan of this strategy, but we have to describe it from product to product. Yeah.
Maybe another question in the room?
One question. Robert, Kai here. Just a question. The example XML of this COD you showed, how has this been created? Because you mentioned there's currently a lack of professional authorizing tools. Is it done manually?
It was done with Altova XML Spy. So yes, in a way, manually. Yeah.
Okay.
But there's an XSD file, there's an theme available for this. I can also send it to you or to the group. This is almost public. And with this theme, with this XSD, at least it's possible to create IFC XML easily, but half manual. Yeah.
Good. Thank you. Any other questions in the room? I can't see the chat. Now I see it. So then we have to look where we start with the new session.
No.
No.
Nothing in the chat.
There is no new question for you in the
It's just
chat.
me and Hansueli in the chat. Yeah.
Yeah. So then, if it's okay, then we switch over to the next presentation from Hansueli and Morten. Morten is here in Montreal in the room. Hansueli is somewhere around the world virtual. I expect Switzerland, but I don't know. So then we switch now to Hansueli and Morten here on site. So thank you.
Well, good morning, everyone here in Montreal, and hello to everyone online. Thank you for having me here. And after this very technical insight of Robert, I would go back and have a broader look on the matter of product data and then inside the BIM environment. And I will later, Hansueli will later take over for the second part. My name is Morten Loes. I'm with Vienna International Airport, responsible for research and development in our newly founded spin-off called VIE Build, a company dedicated to provide services in the BIM environment. And with me is Hansueli Schmid from Switzerland, product manager at Lignum Data, a platform for product information on for the timber industry.
Yeah.
Yeah, just one click. So why do we need to talk about product data? We have made a lot of bad decisions in the last decades. We have heard about that. We've seen the numbers. Often 10 to 13% of the revenue in construction industry is spent on corrections due to the lack of information. Next, like 55% of residue is derived from construction sites or the demolition of buildings. 65%, up to 65%, you have to admit, is inefficient or unproductive working hours. So for this, to make a sustainable world that we need to develop, a sustainable industry, we need to make a change in our behavior. We really need to make wise and fast decisions because the time is running out. We don't have much time to discuss it anymore. We need better decisions. So, to make wise decisions, we need to get knowledge that we derive from information which is based on data. So data is the basis or the foundation of our wise decisions. But without context, we can't have information. I think it was Tuesday when Michael Kennelly said information is data plus analysis. I don't agree with that. I think that information is data and context. In our setting, it's the model. We need the model to put a context to data. Without that, we can't derive information from it. And when we put meaning to the information that we derive from the model, then we create knowledge. And if we truly understand that, we can make wise decisions. So this is the analysis part of our process. So what questions can we ask for from the product data in our model? We can ask for materials. What kind of materials do we have in our buildings? and what quality are those materials or those products. How much of those products do we have in our building, and where are they? What codes do we have to comply with if we use certain products? And this is different to the products we use in construction. And how are those products accessible that we build into our buildings? How can we access them later on? Because this is a life cycle view on the building. It's not for the construction phase only, but later on, we don't know where they are. Maybe we have used materials or products that are of a risk, hazardous. We don't know it yet. Maybe in 20 years we discover that those materials or those products are dangerous. And of course, how can we reuse, recycle, and upcycle, upgrade the building parts, the building components, and the products? We also need to know about the condition those parts are in to reuse them. And of course, how do those products that we use add up to the energy consumption of our construction? They can differ according to the products that we use. If we want to reuse the building or modify it, we need to know how we can exchange specific parts, like we heard from Schmid, the elevator, which needs to be exchanged maybe 2 or 3 times during the life cycle. We need to know about it. And in the end, last but not least, how does the building perform differently if we use different products? We can simulate that in ahead before we construct. So there are a lot of stakeholders in this whole process that are interested in product data. I put it in a circle, not in a typical linear format, because they can appear at any time. Planner can appear again after some years when the building is reconstructed or renovated or retrofitted. So I put some of those stakeholders. There are many more, just as an example, and then I try to put in some use cases. It's only some of them, like the planner would need to know or would research a specific product for its requirements. Then he needs to know about the space that a specific product requires inside the construction. It can differ from product to product. How the interaction is, for example, how if I use this kind of server, what kind of air conditioning do I need? So between those two products, and in the end, of course, comparison, make cost comparison on the long run, simulate how the cost exchange or changes during by using different products. The constructor, on the other hand, might want to know how to customize products for a specific use case. Like we heard from Dirk Hessekamp about construction logistics for specific products. What kind of dimensions do I have on the construction site? How can I transport it on site? How can I deliver it? And on-demand delivery, I could derive from the model product information for which phase and at what time I need to deliver a specific product. The owner, of course, might be interested in cost comparison. When I change a specific product or exchange it with another one, how does the overall cost of the lifetime change? Where does the product come from? Was child labor involved? Who knows? Or have there been any other environmental risks taken into account, or have to be taken into account? Then about durability of the specific product, always considering lifetime of the product, and maybe the quality of the product. Of course, reusability, is it exchangeable, or is it, do I have to throw it away? Does it add up to the huge pile of waste that we already created? The user, who might not be the owner, of course, is always interested in the energy consumption that might differ due to the products used. He might be interested in the capacity of specific products, like what can I handle my piano on this floor or not, whatever. Safety and security issues about a specific product, like what is my door capable of? The facility maintenance, this is something that, of course, for us as an airport is important. Maintenance intervals, inspection intervals of specific products need to be connected to the model, visualized to see where we have those specific products built in. What spare parts do I need to order for specific tasks? And of course, again, energy consumption for the products. How can I change them if I modify product setting? Track and trace, of course, where are those things? Are those products built in, or have they been moved somewhere else? On the administration level, we have huge demand on products or on product data that is used in the building, like the carbon footprint or the energy used, ESG matters, EPD matters. We've heard about that, and taxonomy in the European Union. I'm very happy that Frank Overbeck, what's his name? I hopefully pronounce his name correctly, talked about that on Tuesday in his keynote and explained a little bit about the taxonomy. The European Union regulation for product, services, goods, buildings. So there are those 6 objectives that need to be fulfilled, or at least one of them needs to be fulfilled. Not another objective may be harmed to be declared sustainable building. There's climate change mitigation, climate change adaptation, then sustainable use and protection of water and marine resources. The 4th is the transition to a circular economy. And then we have pollution, prevention and control, and the protection and restoration of biodiversity and ecosystems. Unfortunately, only the first 2 have been described in detail, which is sad. They will be detailed to know what exactly a product or a building has to fulfill to be declared as sustainable. We in the construction side, of course, need the details for the transition to the circular economy. Fortunately, the European Union has provided us with a compass, but unfortunately, it looks like this. It's pretty hard. In my opinion, it should more look like this to reach our goals. So this is something that we need to keep in mind, that we need to make it easier for our customers. We need to make it handleable to provide this data. So what are the requirements for product data? It's need to be machine readable, it needs to be interchangeable, comparable, and unambiguous and unique. Those are things that are already defined. We have those standards. I'm happy that Frédéric introduced them to us. So they are available, and we need to take this to the model. So the important thing is to have the model as the context for our product data. Inside the model, we have products that may consist of different parts, and this is a bit tricky. We have the construction object. I have to admit that might not be the right term. This is an element, that is a component. It's an IFC building element, and then we may have inside different components. So the product that is sold may consist of many different products, and if we want to add product data to our models, we need to know where to put it. So the whole construction can have a different setting or different properties, different values than the single products used inside their values. Here, for example, if you take a wall, it might consist of this inner load-bearing layer, and coverings, and all those are different parts. They can, for example, be defined by IFC material layer. But they can also be component parts. So, one next, please. Yeah. So we have product data that is dedicated to describe the whole part, and product data that is dedicated to describe the component parts. And then again, we have to if we want to stick to the standard, to the schema, to the IFC schema, we have to use the already described properties, and we have also additional unique or customized properties. So this could be a process, how to bring the data into the model. We have the, wait a minute please, we have the data templates which can be defined, for example, at CoBuilder, with CoBuilder define. Be taken to ESD. This has already happened, for example, for the timber industry. I think that Hansueli will talk about that later on. And from BSCD, the manufacturer can derive those data templates and specify them with their product data, with their values, and offer those data sheets for the customers. So, but then we need something to distribute it into the model to the right place. And I put it here like MVD, IDS, API. I don't know. I don't know the solution. This is something that I'm looking for, that we are looking for. And then we have to take it into the model. And again, distribute it to the right place. Find the right data which belongs to the components and the data that belongs to the construction object or to the IC build element. And it does not matter where we host the data sheets. I heard, meanwhile, that it's not possible to host values on BSD, so forget the first part, but we can distribute it from platforms like Data or Data House in Austria, or from manufacturer sites. But in the end, we need a mechanism to transport it into the BIM applications or to the IFC model. The alternative, of course, is to link the data. We can just put a grid into each place, into the component or into the IFC element, building element, and link it to data bases where we can derive the data, product data from. But in the end, we might need both. There might be a phase within the life cycle that the data needs to be frozen. So I tried to put pros and cons in here, but then I decided that it's not a good idea, but because it depends on the use case, whether to use a linked or integrated way to get data, product data into the model. But in any case, we need this technical solution, or I'm looking for this technical solution, how to bring the data into the model, product data. Yeah, I think that's it so far from my side, and then I would like to hand over to Hansueli.
Thank you very much. So, welcome from my side. I'm here now in Switzerland, in Bern, capital city of Switzerland, and I have the pleasure to present you today our perspective, from our perspective. So, we as a wood industry, we have the objective to provide the information of wood products, and so that's the motivation for us to build this bridge, as you can see here, between performance and requirements. So I put this symbol from a bridge to show a bit how it should be in the planning. We should optimize between performance and requirements, and this is like a back and forth, and until we get the optimal result. But at the moment, it's not like that. It's more like we just make the easiest way without a lot of optimization. And this we want to change with the help of BIM. So this bridge between requirements and performance consists of multiple players. We had before, we heard Morten from the side of the requirements, the planners, who have designed something and have requirements on products and components. And I am more from the right side, from the performance side, from the manufacturer side, which produces products and components. And then we have a specialist planner, which together work with architects to reach the optimal solution. And the algorithms, BIM, is our tool to help us through this process to optimize the building. So we have many different requirements on building, and in the European law, it is separated in 7 different basic requirements. And today we draw our attention to the sustainability of building. When we optimize buildings, it is always dependency from building design to components to products. So the architect is coming from the building design down to the product, and the industry is producing products which result in components for buildings. And components are the ideal level to optimize in early planning stages. So those are mostly generic solution components which are used in early planning stages. If we dig now deeper into the topic of sustainability, we see why actually we have to care about this. It's because the construction has a big impact on our environment, and globally, only the production of concrete has more impact than in a whole year. And if we would add steel, which is another 8% of the global emission, we would have 16%. And we talk a lot about the aviation, but this is actually creating 5%, around 5% of the global CO2 emissions. So it's really an important topic we have to keep an eye on. It's not only to change from concrete to wood or something. We can also optimize buildings by using concrete and steel, but this topic really makes more attentive to the use of raw materials, and can certainly also incentivize circularity. So this is our challenge of our time, to find the balance between biosphere, the nature, and technosphere, the human, and to check where we can use more renewable resources and where we have to use non-renewable resources. And that's our motivation. That's why the wood industry is pushing this topic forward, because we cannot only say we are sustainable, we have to prove it at the end, numbers. And also, we've heard it before, the government is setting up requirements, taxonomy, European taxonomy, for example, to have a common understanding on what is sustainable investment and what not. And this touches also the buildings. But the taxonomy will not recognize this topic of the impact of raw materials as long as there are no safe ways of calculating this. And so we have to provide a solution to actually bring this topic into the taxonomy. And so far, this topic is not included. It is mostly focused on the efficiency in the use stage. So what do we have today? So some companies are providing EPDs, environmental product declarations, and also we as an association, we provide generic EPDs. That means we measure the impact of construction material in the life stage of production and disposal. And we declare this then in according to a standard. In Europe, we have the EN 15804, which is the EPD standards, which is defining the life cycle stages and also the different environmental impact indicators. So here we see the life cycle phases and stages, how they are structured. And this is then the EPD, how we declare the performance of the material during the life cycle. So we can find the same structure. And vertically, we have then the different impact indicators with the different values and units. So this is a PDF now, and it's not machine readable. And even if a company would make it digital, a database, it's still not exchangeable because all these life cycle stages have no GUID, and also the impact indicators have no GUID, so it is not machine readable. So this is actually now the work we have to do. So companies at one side have to structure their data, and on the other side we have to make it machine readable. And to make it machine readable, it is makes sense that associations try to take care of it on international level. And here again, you saw this life cycle stages and indicators. So you see the different types of information we have in this context. Here again, we see the EPD, and then we structured the data first. We started with the Excel, like many times. We collected these life cycle stages according to standards. They have also these short names. And we collected all the possible environmental impact indicators. We grouped them together to make it also a bit logic later on in the BSDD, how to find together this information. And now we are very proud to present you here the first time the introduction of this information in the BSDD. So we have now all the important environmental impact indicators available with machine readable identification. And also the life cycle stages are here. So this is the human readable level, which might be still improved a bit because it's not always easy to find the information if you browse the website. But at least it is perfectly available for a machine readable level via API. And we made already first tests, and it's actually quite easy to use. The next step is then to connect this information with different classifications. So this is not excluding any classification, not even IFC, but so this is also a change in my perception of how to proceed. First, I always thought we have to define, first of all, property set, IFC property set, and IFC entities, and now I switched more to this machine readable level, which can be then connected with classifications if needed. So it's then up really to the CAD program companies to decide if they really want to have this properties in IFC, or if they just rely on BSDD, and so it is with all the other classifications. And that allows then really the permeability or the connection of all the information through all the stages from the material, from the raw material to the component to the building. This structure helps here, but it helps also through the planning in the switch from generic to specific. I always change some products, and that must be consistent over the whole planning phase from start to end. So what we did now on European level, so Lignum as an umbrella federation of the Swiss wood Swiss wood industry, we decided together with other countries to start to collect properties from standards, from construction product standards, because standards are only translated in human readable languages, but not in machine readable language. And so far, this is not an integrated process. So associations have to pick up the standards and translate those properties into a machine readable database. And we did that together with CoBuilder. We have then we provide then this information on a public website for free to everybody, so that the industry can pick up those properties and provide their performances of their product by themselves. And we saw that image before, this dependency. Yeah, maybe you start with BSDD. If you define something generic, maybe you start with the standards and put it then into BSDD. So these standards have a very important role here in the start of the definition. And then it's still up to the associations or the industry to define which information is really important and in which context they have to be provided. And at the end, the manufacturers can provide this information in a decentralized way, and the algorithm can put everything together without any problems, because everything is aligned. And to finish, I would like to show you what we did in Switzerland. We heard before about components, and we started actually with the components because this is the ideal communication level together with the architect. We have then also this environmental impacts for each component visible. And we have for each component the IFC file where this information is packed in, and actually someone can import it. But this still is not including these new GUIDs we developed now. So next step would be to enrich this IFC with this new GUIDs, which make it then easier exchangeable between different softwares. And what we have now is also that we have an API, so different companies or plugins can pick up our information and make added value out of it. For example, we have in Switzerland a plugin named GreenBIM, which allows buildings to optimize in early planning stages. Here again, this is also something which is then easy to use for architects and based on components. So we are pretty ahead in the industry, but we now need also the other sides. We just can only build the bridge from the performance. We need now also the side from the requirements. The tenders must be written accordingly, and so this is something we have built together. And I'm happy to work together with Morten and also Christoph Eichler and other colleagues on this topic. I can conclude here. Thank you very much for your attention, and I'm happy to answer your questions.
Great. Thank you, Hansueli. So then we can open the plenary here and also virtual outside concerning the presentation that came from Morten, but also Hansueli. So if you have still questions open for Morten, feel free to ask them also now. I think there is nothing new in the chat. Is something in the room? Questions for Hansueli or for Morten? Yes, please.
One question regarding the construction object definition. How do we attach component information to non-visible things? For example, a layer of glue. So things that are not represented as a component, but we still need to convey important EPD information. Is there any?
But does it have to stick to? You mean it has to stick to a layer? Yeah, I know. But it could be depicted to an IFC material layer, for example. Wouldn't it be possible? Because it does not need to carry anything.
Yeah. But I get from your answer there's no real answer for that. Okay.
I can answer that, but maybe someone else.
But comment on it. It's a often brought up challenge. So I would try to either, if you have a glue that's on some kind of component, stick to something, and if that's not mold, that kind of might be connected to something else that is mold, and then you add it to there, you can add it to the glue. Okay. You just have to connect it to the closest thing in the sense, okay, at least you get it in there. It's not perfect, but it will take some time before the model absolutely everything there. Yeah. So we have to attach it to whatever is there. Right.
And there's a role for specifications in this sense, because these are non-visible items, but there is work related to it. Somebody has to put the glue on the wall before you can do anything else. So you might envision that the object as a total has multiple specifications to go with it to explain what's in it.
Yeah.
Well, that's the important part. So we are also working on this. We are naming it currently the composite information model. That's the aspect that you have quite a lot of information that you do not model. So that you have immaterial information. Could be complex, could be work, could be even material that you don't model. But however, you need the information at the end of the day. So because in the specification area that Rockbound mentioned, hope that we can show a little bit more in Rome, perhaps, now from my organization, from CRV, because we are working on it, and we should have a prototype ready, most probably where Rome could fit. But it is a huge topic, yes, that there is much more than geometry and much more than model.
But then again, geometry or at least dimensions are important. So the context, like where is it placed and how much space is covered with glue, is important to calculate and to process this data.
If you talk about glue, for example, yes. If you talk about, for example, aspects of security and risk management on the construction side, then you even do not have a geometry or a geo context. But however, you have to to specify it. It will have a price tag. You have to manage it. I think these are aspects that are not yet covered in the overall concepts.
But actually, regarding the security topic, it has a geolocation. I have like excess risks at my asset at specific spots, so I can depict them to or attach the risk to a specific location. Maybe not to a specific material or product or whatever, but I can localize the risk.
Yes, of course. There are risks that you can localize, and I'm talking more about the specification. So if in a contract you give advice or requirements concerning risk management on the construction site, then most probably it's not yet localized, but it's still something that you have to manage.
Absolutely.
Because it's part of the contract, it's part of an agreement, and at the end of the day, it's valid for a construction site, and that you have to fulfill. So therefore, you have to have the information that you have to fulfill. Other questions? I know you should see the chat, Hansueli, Robert, but I think there is nothing new in the chat concerning questions. Is there anything else out of the room here? Yes, Roger.
Hi, Roger. Remembering a lot of people online. The question I'm going to ask, and maybe this is already covered in some way, but I saw the use case for having the product manufacturer provide the information. I'm wondering about the reverse of that, where the asset owner can say, I have this requirement, can you find me the lowest, the best environmental solution for it? And I think you probably envision that, but I wondered about how this helps that to work. So I see that maybe driving this more than the manufacturers being the push out if we have the asset owners doing the pulling.
I mean, bringing together specification and product information so that you can search best fitting products for a specific specification.
Yeah, I know we have an owner that has a product, a model of requirements, and they have made the determination that these are the kind of products they need to meet their needs for function, aesthetics, etc. But I think they're not thinking enough about the environmental impact. And I've also know that some owners don't know how to make those comparisons, and so I don't know how we can turn the problem around and put it to the suppliers to solve the problem for the demand side, the buyers.
Yep.
I wouldn't have the answer, but actually it is the requirement that we are facing now from like the European Union when they demand this data to certify a building, for example, then the process would be designed to certificate. So we have all the requirements that we could maybe derive from the taxonomy with a specific data and give it to our model, and then have someone design the product that meets those requirements. But I have no answer to the technical way how to deal with it. But it's more a process.
Yeah. This is at the moment with the construction product regulation in the EU, the question. There is a belief that you can solve the problem of environmental impact of buildings by restricting products or defining the environmental impacts on product level. But it's actually you should do it on the building level. It's actually like you can refrigerator. You can give a label to a refrigerator, but it makes no sense to give a label to a screw of a refrigerator and single parts of a system. So it's always the system, and therefore we provide the information based on on components, so systems which result in a wall or in a ceiling. Then you can start to compare different systems, but only on the product level, it's more important to have the numbers and the impact values. But it doesn't mean if this is a good product or a bad product. It depends always on the performance and the quantity in the system. And I think it would be a danger to go ahead like the European Union is trying to do it now, by starting to set categories or performance levels on products, on the products alone. This is certainly not the way to solve it.
Sky, please.
I have just one comment on what you said. I think what's done here is the basis for manufacturers to offer their data. But I'm totally with you that the force is coming either if the customers request something, or if they see a huge benefit in their own processes. And that's what we achieve here. We can connect with this digitization of the data. We can connect the building digitization with the manufacturer digitization, whereas currently there's a gap. At some point, someone says, okay, order this thing, and then people start writing it manually. And here, I think we have a big chance. And then I think manufacturers can see, oh, we can get better, we can streamline our process here.
I think it's a very complex topic also, because what mentioned now also Hansueli is then the construction product regulation. So now it's again Swiss topics, so representing not now myself as the chair of the product group, it's as the CEO of CRB in Switzerland. So we engage on one hand in this construction product regulation, and one request is that please, if you revise it, make it machine readable and not text. Then we work on this composite information model to have structured way and machine readable way of specification. And on the other hand, we engage on the manufacturer side, that we at least get kind of a mapping engine or an API infrastructure, so that every manufacturer is able to map his information, his product information, to the data structure where we specify it, and then bring in and also the product regulations. So that would be in a way the vision, but it's a very long way to go. It's that complex, that many stakeholders, and even if we succeed, I think we probably have power to do it in Switzerland, but it should be a global solution. And of course, if you take all the regulations, so ISO 7 and so on, that's fair enough, but it's probably not yet the global solution. It helps perhaps in mapping, in bringing together different concepts and systems, because it's at least in a structured way and hopefully machine readable, but still it probably will have in every country some kind of specialties. At the end of the day, especially if you take a global manufacturer, the wish of a global manufacturer is I provide my information about products to the market, and the market can work with it. But they don't want to have a specific structure in every country, in every region, and so on and so on. For me, it's a long way to go, very long way to go.
Yeah, but we need to work on this a lot.
Sure, that's what we hear.
But I think it's interesting working with our owners that have some power, that they can maybe do more, certainly than they are. Maybe we can, I can see we can get them to be more conscious and ask for things. And of course, we need the structure then to provide it. But,
The big challenge there I see is that the largest owners are public, and public owners are not allowed to give guidelines, to ask for specific structure, for specific systems, for specific environments. So they have to leave it open.
they can't set requirements. They can't set requirements.
Yes.
Yeah.
That's always a political discussion. That makes it not that easy. But it's the larger part of all this. So we also have to work on this part. So any other? Yeah.
It should be the goal that environmental indicators are harmonized and then also become a possible requirement in tenders for public procurement, and that then it is also WTO conform. And I guess we're on the way to it. So it will start certainly a new dynamic, and we made now the first step by providing the structure of the life cycle phases and the indicators into the BSDD, and that is now certainly the start to this competition of environmental impact reduction.
At least I think there's an agreement that there's a need. Yeah. Good. Anything else out of the room or from Hansueli, Robert, or the audience in virtual room? Nothing in the chat. Nothing here in Montreal. So then, thank you very much. We are slightly earlier than we planned. I think that's not too bad. Then we are first at lunch, so that helps. So thank you again, Hansueli, Robert, Morten. Thanks. Have a nice evening in Germany and Switzerland.
Just looking
Bye.
for Jason.
Jason. All right.